Hi guys, welcome to today's class. Today we're gonna do a new chapter. It's factorization. So let's get started with this. Okay, let's go over the terms. A factor, right over here. A factor. Factors are the numbers you multiply together to get the product. For example, 1 times 12, 2 times 6, 3 times 4, all equal to 12. So we know that 1, 2, 3, 4, 6, 12 are factors of 12. Similarly for example, 8. 2 times 4 and 1 times 8 are equal to 8. So 1, 2, 4, 8 are both factors of 8. Like they're all factors of 8. So a divisor is a number which divides the given number without leaving a remainder. So for example, 6 divided by 1 is 6, 6 divided by 2 is equal to 3, 6 divided by 3 is equal to 2, and 6 divided by 6 is equal to 1. They're just basically factors, the quotient, or the divisors. Since as you can see, the divisors are in the quotients also. For example, you can see there's a 3 over here, a 3 is right over here, and there's a 3 also over here. Alright, back to our number 8. Notice that if there are 4 factors, 1, 2, 4, 8, which means that there are 4 divisors, 1, 2, 4, 8. Since 8 divided by 1 is 8, 8 divided by 2 is equal to 4, 8 divided by 4 is equal to 2, and 8 divided by 2 is, 8 divided by 8 is just 1. So basically, the divisors are basically the factors of a number. Alright? Multiples are the products when you multiply 2 or more numbers. For example, 24 is 1 times 24, or 2 times 12, or 3 times 8, or 4 times 6. So 24 is a multiple of 1, 2, 3, 4, 6, 8, 12. And 24. What is a prime factorization? The prime factorization of a number is to express the number as a product of factors that are all prime, meaning that you simplify it to the smallest amount. For example, say we got the number 8 as before. Now, what if I all the numbers when we multiply together that equal to 8, but they're all prime? That should be, or the factors of it would be 1 and itself. So how do we do that? First, notice that 2 divides into 8, or 2 is the divisor of 8. So we can start off with 8 is equal to 2 and 4. This diagram is how I like to factorize and get the prime factorization. We split it. It just simply can say 8 divided by 2 is equal to 4. Alright? Now what happens to 4? Well, 4 can be divided into 2 can divide it into 4, or 2 is a divisor of 4 also. So we can write a 2. But once we divide, we get another 2. So 4 is 2 times 2, and 8 is just 2 times 4. From here, we got 2, 3 2's over here. These are all we can have left, since 2 is a prime number. Why? Because only 1 and itself, 1 and 2, divides into 2, which means we simplify it to the least possible numbers, or the least numbers that are prime. So we get 2 times 2 times 2 as the prime factorization, or 2 to the third power. Now let's move on to the fundamental theorem of arithmetic. Any composite number besides 0 and 1 can be written as a product of prime numbers, and this expression is unique. Clearly, we did it for 8, and you can go ahead and prove it. There's a really good proof for it. And this is a theorem, so it means it's true, 100% true. So this basically just telling you, say we got 1,576,382. This number can be factored This huge number can be factored into prime numbers. And I'm not gonna factor it for you guys. You can just put it in the calculator and try to factor it. I'm not doing the math. But this for sure is factorable. Alright? And these are examples of showing 36 in prime factorization. But now let's move on to 1.3. A method of prime factorization. We're gonna use it on problems. Example 1. What is the largest prime factor of 189? Let's go with this question and tell me your answer to chat. In private message, please. Alright, let's get started with this question. So basically, what is the largest prime factor of 189? From here, we do the same method as we did before. 189, we can split into, what's the first thing that comes up to your mind? Well, 18 is divisible by 9, and 9 is divisible by 9. Or we can just add up the digits, and we notice that it's divisible by 9. So, this number is divisible by 9. So we get 9, and once we do the division, 21. Alright? From 9, we can split it down to 3 times 3. So 3 times 3 is 9. 21 can similarly be split down to 3 times 7, which means the prime factorization is 3 times 3 times 7, or 3 cubed, or 3 to the third power, times 7. But what is the largest prime factor? Well, we could just look here, but it's good to write the prime factorization. So as we can see from here, the largest prime factor is 7, or C. Alright, let's move on to 1.4. For an integer n greater than 1, an integer is just a number that can be negative or positive, but it's just a whole number. There's no fractional or decimal parts. But in this case, this integer n greater than 1 is just a positive integer, but not 1. Let the prime factorization of n be p to the 1, p sub 1 to the n, or a random prime to the n, random prime to the a, times random prime to the b, a random prime to the c, and so on. Or he could say it's basically a random prime. It's basically any prime you can have to the a, any prime to the b, any prime to the c, any prime to the n, where m is the number of whatever number you like. And these are just prime numbers. Alright? The number of divisors is just exponents added to 1. For example, say our factorization is 144. We have this number 144. Factorizing it will give us, what is it? 2 to the 4th times 3 squared. Alright? From here, if we apply this formula, the number of divisors is just one of these exponents plus 1 times one of the other exponents plus 1, and so on. For example, let's say this was 2, 3, 5, with the corresponding be 6, 8, 9. This is just 6 plus 1 times 8 plus 1 times 9 plus 1 for the number of factors in this expression, or number of factors in this number. 2 times 6, 2 to the 6 times 3 to the 8th times 5 to the 9th. You do this, the number of factors. Well, okay, from here, what's 6 plus 1? It's 7. 8 plus 1, 9. 9 plus 1, 10. Multiplying this all out gives you 630 factors. So in this case, there's 630 factors. You can similarly apply this to 144. There are two exponents, 4 and 2. Or 2 to the 4th times 2 to the squared, you get the two exponents as 4 and 2. Doing the same process as we did before, 4 plus 1 times 2 plus 1. This gives you 5 times 3, or 15. Alright, so there's 15 factors. This is including 1 and the number itself, by the way. Alright? Let's move on to example 2. How many factors does 2 cubed times 2 to the 6 times 5 have? I'll let you guys have a try on this question and tell me your answers through chat. All right, let's get started with this question. So basically, the number of factors in 2q times 3 is 6 times 5. This is just 3 plus 1. As we talked about that process before, 3 plus 1 times 6 plus 1 times 5 plus 1. From here, just doing the multiplication gives you, and addition is just 4 times 7 times 6. From here, you just get, first we can multiply the 6 times 7, or you get 42 times 4 gives you 168, if I'm correct. Oh wait, my bad. This should have been a 1. Since 5 to the 1 is just, the exponent is just 1. So, make sure you read the question carefully, alright? Or you should make these small calculation errors. So in this case, it's just going to be 2. So from here, you get 4 times 7 times 2, which is clearly 56, or A. So the answer is just A, or 56. Now let's move on to example 3. How many distinct positive integral factors would the following product have? 12 times 15 times 17. I'll let you guys have a try on this question and tell me answer to chat. All right, let's get started with this question. So how do we post this? Well, notice that from here we're gonna do let it be 12 times 15 times 17. Well, notice that 17 is already a prime number by itself, so we just leave that to be. For 15, we can split it to 3 times 5, and 12 we can split it to 3 times 2 times 2. All right. From here, you can get 2 squared times 3 squared times 5 times 17. All right. From here, doing the same thing as we did before, add up. This gives you 3 times 3 times 2 times 2. This is just 36 or D. All right. Now let's move on to example 4. How many integral factors does n have if n is equal to 6 squared times 15? All listeners have to try on this question and tell me the answer through chat. Alright, let's get started with this question. So basically, how do we approach this? Well, first off, we do 2 squared times 3 squared inside, 2 times 3 inside the squares. Make sure you factor this first, or else you're gonna mess up. So 15 can also be factored into 3 times 5. From here, we can split the 2 times 3 of that squared into 2 squared times 3 squared times 3 times 5. Continually simplify, we do get 2 squared times 3 cubed times 5, or the number of factors is just to become 3 times 3 plus 1 is 4, 1 plus 1 is 2. So we answer get 3 times 4 times 2, or 24, or D. Alright, now let's move on to find the number of even divisors. So, what prime factorization of the given number, take out 1, 2, calculate the number of factors of the remaining number. The number of factors of a prime number is even, or 2, or it's pretty obvious. Example 5. How many positive integer factors of 72 are even? I'll ask you guys have a try on this question and tell me just through chat. All right, let's get started with this question. So basically, how many positive integer factors are in 72? Or even. As I said, we can take out a factor of 2 first and get to 36. This can be factored into 2 squared times 3 squared, as we talked about before. From here, we can add 1 to both exponents and multiply them together to get 9 or 9 even factors. Alright, now let's move on to problem 1, or the homework. What is the greatest digit integer that has a factor of 19? Well, how do we push this? Well, we can divide it into every single integer here. We can divide 19 into every single integer and see if there is an integer that has 19 that divides into it. And the answer to this question is just D. Since 988 is divisible by 19. You can check it for yourself. Which is just 52. Now let's move on to problem 2. Let a PRD number defined as one in which the product of the positive divisors of the number, not including the number itself, is greater than the number. Which of the following is not a PRD number? I'll let you guys have a try on this question and 10 minutes to chat. All right, let's get started with this question. So basically, let a PRD number to be defined as one in which the product of the divisors of the number, not including the number itself, is greater than the number. So the following is not a PRD number. Well, how do we do that? Well, how is that possible? Well, let's check that out. 12 is a PRD number. All right, that's for sure. 18 is also a PRD number. Why is it that? Since 2 times 9 is already 1, 3 times 6 is already 2 of these copies. So that's for sure not a PRD number. So from here, we can let it be 27. Why? Since from here, there's the factors. 1, 3, 9, 27. 27 doesn't count. As I talked about, we do not include the number itself. So we're stuck with 139. But in this case, this multiplies up to 27. But that's not greater than 27. Alright. So the answer to this question is just C. Now let's move on to problem 3. If one of the positive factors of 120 is to be chosen at random, what is the probability that the chosen factor will not be a multiple of 5? So basically, how do we post this? Well, first off, you want to find how many factors are there in 120. So how do we post this? Well, 120, this could be factored as 5 times 3 times 2 cubed. Alright? So from here, the number of factors in this is just 4 times 2 times 2 is equal to 16. Alright? So there's 16 factors. Well, how many are there? How many are multiples of 5? You can divide by 5 we can do 120 divided by 5 to find the numbers of factors by finding the factors of that number when divided by 5. Or it's 3 times 2 cubed. Doing it gives you, there's 8 factors. That are not multiple of 5. A multiple of 5. Why is that? Because you can count it this way. 5 is a factor, 10 is a factor, 20 is a factor, 15 is a factor, 30 is a factor, 40 is a factor, 120 is a factor, and 60 is a factor. These are all the factors that are multiples of 10. From here, you get 8. And then 8 divided by 16 is just 1/2. So the answer to this question is just 1/2, or A. Alright? Now let's move on to problem 4. In the equation, x to the y is 8192. X and y are positive integers. What is the smallest possible value of x minus y? Well, notice that you can get this 8192 by doing 2 to the 13th power, or 2 multiplied 13 times. So what is the smallest possible value of x minus y? Well, this is just 2 minus 13, or negative 11. So the answer is just B. Alright. Let's move on to problem 5. How many positive integers less than 100 have an odd number of factors? Well, how do we approach this? Well, first off, all the square numbers have odd numbers. Why? Since, what is a square? This is just a number, say 5 raised to the second power, or 5 squared. Just like that. Well, notice that this 5 squared has factors 1, 5, 25. That's an odd number of factors. So, notice that there's 9 possible squares less than 100. So there's 9 possible numbers that have an odd number of factors. So the answer is just D. Now let's move on to problem 6. What is the sum of all prime factors of 71,400? Let's take a try on this question and tell me what you have. Alright, guys, let's get started on this question. Oh, hold up. What is the sum of all the prime numbers of 71,400? Well, we can split this to 100 times 402 times 7, which we can continue to split it up to 3 times 34 times 7 times 2 squared times 5 squared. Which then you can split it to 2 cubed times 5 squared times 3 times 17 times 7. And then you proceed with the formula. You can get 4 times 3 times 2 times 2 times 2, or a grand answer. Oops, my bad. This is not find the number of factors. Oops. Make sure you read the question. It's a sum of all the prime factors. So there's normally 5 prime factors. So it'd be 2 plus 5 plus 3 plus 17 plus 7. And from here, adding all of this up gives you a total of 34, or B. Alright. Now, let's move on to problem 7. How many odd positive integers are factors of 480? Well, first off, we can just remove every single factor of 2. Alright? That's just gonna be, there's gonna be, 240. You can divide by 2 again. To get 120, divide by 2 again, it gives you 60. 60 divided by 2 is 30. 30 divided by 2 is just 15. If I'm correct, it's gonna be a 15. So that's gonna be 1, 3, 5, 15. Since 15 has 4 factors. 1, 3, 5, 15. From here, the answer is just gonna be E, since they're all the odd positive integers that are divisible, that divide into 480. Now let's move on to problem 8. How many positive factors of 36 are also multiples of 4? First off, we can divide by 4. Why? Because that way we know it's already a multiple of 4. Which means that we're left with 1, 3, and 9. Since we get 9 is left, after we divide 36 by 4 to get 9. Since all the factors are there, it's just 1, 3, and 9. So we know it corresponds to 4, 12, and 36. And these are all the factors that are multiple of 4. So there are going to be 3 factors that are multiples of 4. Alright? Now let's move on to example 6. How many positive integer factors of 72 are also multiples of 4? Same exact strategy. We do 72 divided 4 to make sure that the number after it is always going to be divisible by 4. So this just gives you 18. So we can find any factor for 18 and we multiply that by 4. This is going to be a factor of 4. A factor of 72, but also going to be a multiple of 4. So how many factors are in 18? Well, that would be 1, 2, 3, 6, 9, and 18. Those are a total of 6 factors. So from here, we know that there's going to be 6 positive integer factors that are divisible by 72, that divide into 72, and are multiples of 4. So the answer is just E. Alright? So that's it for today's class. I hope you guys have a wonderful weekend. I'll see you next week. Bye.